Everywhere you turn, things are turning around you, spinning, rotating. Take a look. Imagine how many billions of rotating machines are at work. In factories and homes, on the roads, in the fields, and in the air. Our job is knowing those machines inside and out, ensuring they rotate reliably. Even though each industry has different needs, each customer its unique demands, one common denominator is always the demand for lightweight products that produce less friction. Minimizing friction is what we've done for more than a century and what we'll continue to do. It all began with a robust bearing design. That design was born from a dedication to research and development across all industries. R&D isn't just about product development. By testing new technologies in our own factories, we can take what we've learned and put it into practice out in the field. The Industry 4.0 revolution has already begun at SKF. Digitalization in our factories is improving efficiency and performance, making processes smarter. The bearings themselves are becoming increasingly smarter. By monitoring vibration, load, temperature, and speed of bearings, we can tell a lot about the condition of rotating machinery. New technology can now even provide that data instantly, which means maintenance can be planned and problems fixed before breakdowns occur. And that adds up to more uptime, a must in any competitive industry. Analytics are critical to those who perform the maintenance on the machines and design the products inside. It's key to collaborate with customers in the design process to make improvements for their specific needs. If there was just a little less friction and less weight in all we designed and built, imagine the possibilities.
We are truly everywhere.
And that's never going to change.
Because everything around us
will keep turning,
spinning, rotating.
We are creating a world of reliable rotation.
So our crusade
against friction and weight continues.
That work will never be done.
Will never be done.
Will never be done.
It's a never-ending story.
Thank you. That's a brief introduction to SKF. And it's interesting, we talk about digital now. And we could even say we've been doing digital for over 10 years as we've been inventing new services and solutions for our customers, including the condition monitoring solutions that we were been talking about earlier. I have to remark, we're having a technical problem here. I was in a presentation last year where somebody from Salesforce was doing the presentation and the actual projector broke during his presentation. So he had to give his entire presentation with no slides. So here, I'm going to have a go at doing this now for the next couple of minutes while things change over. SKF has been around now as an organisation, as a company, for over 110 years. And we have about, our annual revenues are in around about 75 billion SEK. And we have operations in countries, in over 130 countries globally. Just to give you an idea, each one of you today will come into contact with about 150 bearings. You won't notice it most of the time, but it'll be in the cars you drive, maybe the plane you fly home on at the end of today, or when you get home, it's on the skateboard your children may be using. And out of those 150 countries, we have over 50,000 distributors globally. So another useless fact you may say about SKF is you're only ever 50 kilometers away on the Earth's surface of actually getting hold of a distributor and getting hold of one of our products. Sorry. That's okay. Oh, 72.7 million SEK. We have factories in over 108 countries in the 108 factories, in 24 different countries in the world. We have a global workforce of close to 45,000 people, and the majority of those people work in our manufacturing operations. So we are truly a global manufacturer, and truly a manufacturer that will be impacted by the digitization within manufacturing and operations. I some of these slides are a kind of a reflection of where we are in the industry. This is a picture of Hannover Messe the other day, and you always find these pictures, which is great. Everybody's walking around today with the Microsoft HoloLens or Google Glasses, yeah? This is digitization in the form of marketing. We hear about this. I mean, everybody's talking about it. You know, you see some of the companies like the GE and the Predix platform. You know, the SAP we saw yesterday. We see PTC with their ThingWorks applications. Everybody's showing it. And even last week in the Paris Air Show, the HoloLenses, which obviously they want to reinvest and reuse in every conference they go to, came out again. Everybody's talking about this. So it is absolutely, we're in the middle of a buzzwords. And also, by the way, we always get a slide with somebody drinking beer on. I don't know how this guy's clearly taking this conference seriously. But to drive my concerns around the world of digitization, there was a report released by IoT Analytics, and they did have some caveats and disclaimers about the top ranking companies around predictive maintenance. And as you can see, IBM, SAP, Siemens, even ourselves with our own condition monitoring solutions are on there. So this is great. You can see who are the leaders in the predictive maintenance space. Then the question comes, how do they determine this ranking? Well, the first criteria is how often do they appear in Google searches. Now that's, you may see, if you know enough about the internet, that can be slightly manipulated. Secondly, how often the words predictive maintenance was used in press, there's an obvious reason there for it, and also blogs. The final criteria for determining the ranking, which I think is absolutely the best, how many people have the words predictive maintenance in their job title on LinkedIn? Now, this is a joke, but it's very, very serious about the maturity of our industry. If we think about predictive maintenance and we judge how good companies are on predictive maintenance by Google searches, mentions in the press, and job titles in LinkedIn, we've got quite a lot of work to do. So I refer to us as being in the middle of a digital gold rush. We have had various terms on this. And if we look back into history around the Californian gold rush, who made the real money in this gold rush? Was it the guys prospecting where they will find the gold? Or was it the people who were selling the picks, the shovels, setting up the restaurants, if you will, cafes or whatever the American would use into that term there? They were the people who made the real money. So all these consultancies and vendors which are now currently staking out their little patch of prospecting what is gold in terms of digital, we need to remember, as often as the clients of this, as customers of this, the real gold is the picks and the shovels. The real gold is the data, the information that goes behind it. Now, I go back to the last presentation was fantastic because it was the statement was made by Philip, which was we have to move away as hardware, as the machine tool manufacturers, move away from just purely looking at the machine capability. This is basically the start of our journey. We are investing significant amount of money, last year alone, around about 500 million SEK, in new capabilities within our manufacturing portfolio of 108 factories. Actually, we're in Germany. Most of those, there were certainly 2 announcements last year on investments we make within our facilities in Germany. Now, how do we start that journey? Well, we start that journey by looking at the machine. We need to make bearings. We want to improve our productivity and efficiency in doing that, cost basis. We start with machine capabilities. And I guess, as manufacturers in here, this is a common thing, yeah? But of course, we're now digital. So the next question we ask is, what about the applications? You know, we talk about the SAPs of this world, we talk about connecting to our CAM solutions, etc. We talk about the applications. And of course, we're smart. we also start talking about the security that we need around it. That too, most discussions that I have internally is the full context of the discussion that we have around digitization. But we haven't quite really realized how to bring this to life. Because if you think solely about machine capabilities and the applications that go behind it and the security, you're missing the big problem. The big problem is that the information that we need is not necessarily available to drive the machines. We have very few standards or standardizations based on the discussion yesterday that determine the language that we need to speak around that information between the applications and between the machines. The maturity of the business processes that we use moving forward into the digital age are not necessarily robust enough to take us forward around that. And finally, is the workforce actually able to utilize these new capabilities and tools? Are the people good enough to use it? So when we look at this in its entirety, we came up with the basis of that the machine performance, which is the traditional way of thinking about how we build a factory, is not enough. This is in the future, in the digital world, will be driven by information. So we started to rethink. We rethinked, I mentioned yesterday, yeah? We have this concept of BEDA, bearing data. That concept existed from the 1970s. It's used for describing the parameters of a bearing, but it's also used for classifying different bearing components, for example. That concept cannot be used going forward. It's culturally, we have to rethink how we do these things. And the premise of that is a very straightforward 4-step approach. We call this connect, collect, correlate, and collaborate. Connecting is about connecting the machines together. But we also have to think about that in terms of connecting our business processes together as well, where traditionally they can be very disparate. We collect the information. We collect, obviously, as we all think about it probably immediately, the sensor information back from the machine so we can use that to improve our performance. But we can also collect information that's driven in the design process in a different way to help form that. Obviously with correlation, then we can start looking at the patterns, the trends, the information that we have. But the true power of the digitization is finally at the end. When we have these pieces in place, our ability to collaborate internally as an organization, within the factory itself, within the supply chain, and with our customers, most importantly, that is down allowing us to unleash the true power of digitization. Some of these slides are basically insights of our organization, which I assume are very similar to many other organizations. And I'm going to start talking here about some of the key challenges as well that we face. So this is the organizational challenge linked to Industry 4.0. This is your business guy. Let's call it finance. Now, finance has his own processes, his own ways of working, and you can see he's got his nice boundary, his dotted boundary of responsibility around him. And here is your IT function in your organization. Very similar, very clear responsibilities, clearly defined boundaries. And there is a determined method of communication. That's the dotted line that goes between them. Let's just complete the diagram. Here's your factory. So here's the factory, its own responsibilities and how it works with the business functions and how it works, for example, with your IT functions. That's how most organizations operate today, clear boundaries. Now we move towards Industry 4.0, where we have business, IT, and the factory itself. The problem is we have this overlap. That the IT function is not so clear anymore. Is that the responsibility of IT? Is that responsibility of the factory? Is the business responsible for some of these components? The factory wants to control it all because they want to make sure that the factory is running optimally. And here's the problem. Every time we have an overlap where the traditional clear boundaries of responsibility were there, we now have a conflict and a lack of clarity, you could probably better phrase, of whose responsibility is what. Now this is occurring in projects today. when we're looking at, say, an Industry 4.0, how do we connect machines? Who's responsible for that? What is the technology that needs to go? How do we implement that? This clarity, this lack of clarity, these overlaps of responsibility now make it a real pain point for organizations to move forward with their Industry 4.0 strategies. Does that ring true? Yeah? A few nodding, thank God. Not just us then. Then let's spend a moment on information. I remember having a conversation with an engineering manager that says a PDF drawing is digital. Is it not? Now, you could argue that yes, it is a digital format, but I call that digitized. And most organizations have a lot of digitized information. The problem is that this digitized information is probably located at, I can pretty much guarantee, can I just quick show of hands, Excel. Who uses Excel to drive their business? You see, that's the world's best ERP system is Excel. Sorry for the German ERP manufacturers perhaps in the room. We have drawings, yeah? But those drawings could be located in shared folders, emails going around. They're digital because they're Adobe PDFs. So, and for us, we have a very big legacy in Lotus Notes. Now, Lotus Notes, you could argue, is digital as well. It is digitized information. The problem is, digitized information is not digital. It is not necessarily structured together in a way that brings context to that information, that allows you to control and communicate that information effectively. It is not necessarily in the right format and a language that allows you to communicate that to a machine on the shop floor. So very much digitized is not digital. But with the lack of standards and common ways of approaching this, this makes this journey very, very difficult. And if you think about it from a business value proposition, there is no value to them. What they do today inside of their silo in their organization works fine for them. That PDF of the drawing is fantastic. Why should they change to a model-based definition that allows you to improve the speed of generating the NC codes to drive the manufacturing equipment? They have no value in engineering from that. Production and engineering, on the other hand, say engineering don't do half the work they should do. Another example of some of the challenges of evolving from a traditional industry, I said we've been around 110 years, to a digital business going forward. I mentioned the word value a moment ago. It is quite difficult to determine what the value of digital is in an organization. Somebody's working against me today. And as I said, I mentioned a second ago, the value proposition is very difficult to actually understand. I mean, digital is not tangible, yeah? So we started off with this concept of, this is our approach to understanding the value, by the way. We have this concept of a world on a page. For a particular product line, we're able to map their end-to-end business process. It's a very, very high level. It's not your traditional Visio diagrams that go really, really low. We managed to fit it on one page. It's very, very simple, very, very useful, by the way, for communicating with executives on the value. And against on that map, we're then able to identify where the process pain points are, where we have rework, particularly where we have issues with information or people communicating and what that causes. We apply what we say, perhaps we call these different lenses to this world on a page. We apply a lens on, say, what steps add value to us as SKF? What steps add value to the customer? Where do we have significant lead time? Which steps have significant administrative processes? And from that, we can then also start mapping against those process steps the information that we use. Now, we use this term digital twin. I said beyond the buzzwords, yeah, at the beginning, and I mentioned digital twin halfway through the presentation. So you're going to kill me. But digital twin is basically, for us, the core information. I mean, you call it the DNA of our business that defines the product and the manufacturing process. There are 5 pieces of information that make that up. And what we're able to do is map, in these information limitations, those 5 pieces of information and understand the maturity of how we create that information. How useful is it in the digital world? And how that information is then connected together. Then we can say, that is the world of today. These are the pain points of today. We're then able to map the future. So if this information was in the right format, connected together in the right context, how would that impact the business? Now, we developed this map in the context of manufacturing for one of our plants in Germany. And we're now running it across all our major product lines to understand the value of creating a digital business. Now, one of the interesting things that came from this is that when we looked at this, we found the value proposition was higher in some of the areas we didn't even expect. So, for example, when we looked at this, we found out that the application engineers that we have out in the field working with our customers, we could improve their performance by over 50% in engaging with the customers around product information. And that ultimately would allow us to allow us to win more business. Now, that's the intangible, but the tangible piece of that is we can improve their performance. And that is by us changing information to support manufacturing. It was quite interesting where we saw these parallel or tangential benefits where we never expected it. So, how do we go from the digitized world of today to transforming this in the digital world to create the digital twin of the future? Of course, we create a data factory. Now, a quick show of hands. When you do transforming data or information, I hate the word data, by the way, it's a very technical word. Information is something that has value. When you transform the information in your business, how many people typically go back to the owner or the creator of that business, that information and say, can you do these changes? So if you want to change the format of a drawing, engineering typically do that. Quick show of hands. Good, few buy-ins. The problem is, engineers are there to engineer. They're not there to manipulate data. We have programs that have been running for multiple years, moving information out of our legacy of Lotus Notes into a different format, a more useful format in a database. We have to think differently. If speed is of the essence, we have to approach these traditional challenges of moving the information along in its maturity, in its formats. And we created this concept for Digital Factory. We have identified a number of partners out in lower cost sourcing countries where they have proven approaches to take the legacy digitized data and transform that into the formats in the language and help us create the structure which gives it context in a more automated, cost-effective way. It is not going to be as accurate as the engineers would do, but I can save years on this journey, and that's a risk we're having to trade off and understand. Next business challenge. Trying to understand digital for many people is like trying to smell the colour 9. It makes no sense whatsoever. That statement makes absolutely no sense, and to most executives that I speak to in businesses, it makes no sense to them either. Digital is nothing until it becomes physical. Until it becomes tangible, nobody really understands what you're talking about. I'm the mad guy presenting some great numbers again, but I still don't know what he's talking about. So we've developed an approach at SKF that helps us move that journey along. So this is, by the way, we recently commissioned our new factory in Gothenburg, which is our first world-class manufacturing factory. So that is one of the robots we have on that line. So that's the physical world. That's the thing that certainly the operations guys know and love. The problem is, when you digitize it, we have to somehow create a bridge between the two that makes these things make sense to people. You know, if you work in the world of physical things, digital, as I said, does not necessarily make any sense whatsoever for you. So we introduced this concept of digital readiness levels. If anybody's familiar with NASA's technical readiness levels, or TRLs, to support product design maturity, We've just basically ripped that off and created a digital version of that. The first step of this is Accelerator. Now, we are in the process of working with a number of strategic partners to create a laboratory environment where we can understand and get our hands dirty very, very quickly with new digital capabilities. So we can take the digital ideas and make them physical very well, very, very quickly. So that's our first level. It's our accelerator capability, the Digital Accelerator Labs. But that's good. But in a laboratory, the first thing is you show the ops guys in the laboratory, go, that's not real. That's not a real machine in a production. So we have demonstration capabilities in our machine development centers, where we can take the concepts from the laboratories and bring them into a real-world environment with machines. This isn't a full production environment, but it's now getting closer and more real. We're getting more and more physical. As our confidence level goes up on this technology on demonstrations, we then have identified a number of pilot factories. Those pilot factories have the right capabilities to onboard those new capabilities very, very quickly. We can then demonstrate that in a full operational environment. And as we get that confidence and our understanding that this stuff would work in reality, then we move to a strategy of global deployment. So this is the journey that we take. It's about risk mitigation, but it's about speed. I mentioned at the beginning of today, the fail fast approach. This allows us to take a very low risk and a very quick way of achieving some of these things, allowing us essentially to fail fast. Now, hopefully, now this is the last piece of technical challenge. In this presentation today, I've talked a lot through PowerPoint slides. So what I'll show you is a quick video of us actually doing this. This is us actually having a fully digitized chain from engineering to the machine on the shop floor. And we achieved this, we talked to hackers last night, yeah? We achieved this in just over 3 months. Shows So that was us actually machining the first ring off a digital twin that had not existed beforehand. But what you saw was some major steps. It may not seem so revolutionary for some customers or some companies, but for us, this was a massive, massive step forward. And to give you an insight, I will be clear, I think it's useful. This was done in October last year. We're now in June. So remember that Venn diagram of responsibilities. My organisation sits on the business side. I'm one of those business guys. I'm not in IT. I work very closely with the factories. But now we've been talking for a number of months on whose responsibility it is actually now to deploy this. Which applications are we going to use? Because there are many overlaps in the applications. It was only this week we finally made a decision to move forward. So it shows you how fast you can move with digital and digital concepts, but perhaps how slow organisations are to actually move forward to be able to implement them effectively within a factory. So that's the presentation from me. That's a little bit of an insight into where we are as SKF, some of the key challenges that we have. It's a little bit more kind of low level in terms of the way we have to move forward as digital and how a company needs to address those challenges.